Welcome everyone to the Java with the Best conference. My name is Reza. I'm essentially a consultant and architect in my day job. It's my pleasure to you to present a talk that really is very near and dear to my heart. It's called Java EE8 and the Open Future of Java EE, What You Need to Know. So without further ado, let me start sharing my screen. All right. So there in the opening screen, you see my name, a bit about what I do, and I think most importantly, my contact information, both on Twitter and my email address. If you should have any questions, please do feel free to reach out to me. Part of the reasons I do these talks is essentially so that you could do just that, and we can help each other out. So as we all know, Java EE is not a spring chicken. It's been around for a really long time. In order to understand where it is today in terms of the Java EE8 release, and more importantly, where it is going in the future, I think it helps a little bit to stop and look at where we have been. So I look at the Java EE timeframe, and I look at it as different phases of its life cycle. Unfortunately, I've been around to witness firsthand, essentially, the entirety of that life cycle. So to me, J2EE is sort of the infancy of the Java EE platform. This is where Sun Microsystems was really trying to define what it means for it to be server-side Java. And whatever you may think of J2EE as a technology, the reality is Sun Microsystems succeeded in creating a successful ecosystem on server-side Java. And in fact, that's why a lot of us still have livelihoods and why Java remains so strong. It has to do with the initial success of Sun Microsystems in defining J2EE as a platform. Now, as we all know, J2EE as a platform, as successful as it may be, wasn't perfect. It had some downsides, in particular with regards to usability. But what happened was that with J2EE, there was enough of an ecosystem created so that the ecosystem would answer and solve questions that perhaps the core standard wouldn't. And vice versa, it's a symbiotic relationship in that while the Java EE ecosystem inspires sort of the ecosystem to go beyond itself, it also, by symbiosis, essentially adapts changes from the ecosystem as well to create a stronger core in the standard platform. And in fact, Java EE5 is an example of both of those things. So Java EE5 adopted some of these changes that happened in open source projects like Spring and Hibernate, and adopted those ideas as a core part of the platform, namely two concepts: POJO-based programming, as well as to a somewhat lesser extent, conventional overconfiguration, the idea that everything should be defaulted, as much as possible should be defaulted in the system for you. The big contribution, though, from a Java EE5 standpoint, from the standard to the ecosystem, is the introduction of annotations. Annotations were essentially created as a way of defining metadata for your application and having that metadata be a first-class citizen of your application model through this intrinsic mechanism in the Java language itself. And really, EJB3 and Java EE5 was the initial proof of concept of making that happen. So all of these changes were fundamentally important changes in Java EE5. And frankly, these are the sorts of changes that are still adopted outside of the Java EE platform. Even today, when I look at various things that are presented as innovations, these are really nothing much more than things that we have enjoyed in the Java EE platform for quite a while now. The two big changes in Java EE6 were really about introducing CDI, context and dependency injection. So dependency injection as a first-class citizen of the platform. There was a weaker notion of dependency injection in Java EE5, but as I said, the primary focus of Java EE5 was really to polish up the core programming model and have that be a strong programming model that we still take advantage of. So what really there wasn't time enough to do was to create a really polished API for dependency injection, and that happened in Java EE6, in addition to some other innovations that you can see on the screen, and also splitting up the platform into two separate profiles. One is the full profile, which includes every single API in the Java EE stack, and the web profile. So this I would describe as sort of solving the same problem domain as Ruby on Rails. It's a simple web application that's a database front end. And I think we'll see these concepts of profiles evolve even further as we go forward with Java E, just as it has in terms of profiles in Java SE platform as well. So in Java E7, the principal changes there was really to make the platform a little bit more forward compatible and to adapt to changes outside of the Java E platform. So one of the key features in Java E7 was the adoption of the changes that are happening in the web standards worlds. So some example of that is WebSocket, the introduction of JSON, which by the way is a W3C standard, into the platform, and similarly a lot of other changes along those same lines to make the Java E platform an effective backend for essentially these web-based rich web platforms. In addition to that, Java E7 had a few changes to really perpetuate and expand the programming model changes in Java E5 to every single corner of the platform. So good examples of that would be perhaps something like JMS, the changes that went in JMS 2.1, and also some core features that were necessary for the enterprises. These are things like batch processing and concurrency utilities and the like. So all in all, Java A7 was a relatively strong set of changes. A lot of changes went in Java A7, perhaps the biggest set of changes in the platform ever. And which brings us finally to Java E8. Java E8 obviously is going to be the focus of much of this talk today. But basically, Java E8 is much of the same along the lines of Java E7. It's about filling out all of the gaps, foreseeable gaps in the platform, making it a little bit more feature complete, and also future-proofing it a little bit. So adding stuff that is happening outside of the platform that the platform should adopt to make sure that server-side Java developers can take advantage of those things. Okay, so this slide, I think, is somewhat relevant because of sort of the, if you will, uncertainties and negativity sometimes around the Java E platform. And so in order to counterbalance some of these things, we as Java E Guardians, and we'll talk about what Java E Guardians is in a second as well, we actually go out and collect all of the statistics that are out there, in particular with regards to polling and surveys of Java E usage. And beyond all of the, if you will, the uncertainties, the reality is the Java E is very, very important. Whenever we do these surveys, what always winds up happening is that, yes, Java E still is very heavily dependent upon, and often more so than any other thing in the Java ecosystem. It's just not as noisy about it. So the reason this happens is because of the next slide that we'll talk about, namely that whether or not people are using the entire Java E stack or not, the reality is that they are critically dependent on at least one, and in many cases, larger parts of the Java EE stack. So that's why Java E continues to really be important, not just for the folks that are using nothing much else than vanilla Java E, but also people that in one way or the other depend on Java E. And in fact, this brings us to this slide, which is the Java E ecosystem. And it's part of what really excites me the most about the Java E ecosystem. So the Java ecosystem isn't just a matter of a small core set of APIs, sort of take it or leave it value proposition. The true strength of the Java E ecosystem is all of the projects and products and applications that build upon it, that extend the Java E platform or implement the Java E platform in some shape or form or the other. And this ecosystem, honestly, is one of the most vibrant out there. There's very few other technologies that are really so heavily dependent upon, and by extension, so really so vibrant. And in fact, one of the things beyond the standard that has risen to prominence quite a bit is something called microprofile. And that is basically an effort by the core implementers of Java E, so folks like IBM and Red Hat and Payara and the like, to bring about some innovative features that are necessary for microservices-based applications. And we'll talk a little bit about what exactly microprofile has. This is not a microprofile talk. Certainly will be a microprofile talk, even in this, more focused on microprofile talk, even in this conference. But I will tell you a bit about microprofile a little bit later. But long and short of it, again, is that it is essentially an extension over the Java EE8 platform that allows you to create microservices-centric solutions and applications. So one of the most interesting parts of Java EE8 in particular is that it is actually an extremely community opinion-driven platform, more so than, frankly, any other technology that has come about before it. And the reason for this is because of something called the Java EE8 Community Survey. And this is really how the origins of Java EE8 came about. Is instead of sort of a group of vendors or some people that you don't know at Oracle figuring out what the future revision of Java EE8 would look like, the way Java EE8 actually came about is through these folks that normally would work behind the scenes, coming up with questions in a survey to ask the community, hey, what do you think about these features, and how would you prioritize them? Well, if we're missing something, tell us what is it that we should be looking at. So the results of the survey was extremely good. We had about 5,000 input points. Many different types of companies, many different developers, certainly well representative of the server-side Java developer ecosystem. And this is really how we came about with the initial scope of Java EE8. And this is really what this slide is about. So as you can see, certain key themes. So as I mentioned, the web standards alignment with work that comes out of bodies like W3C. And we'll talk about each of these features in detail, but simply enumerating it right now. It's HTTP2 support, server-sent events, JSON binding, JSON processing API, and an action-oriented web framework. The other key theme for initial scope of Java 8 was CDI itself. So a large-scale revision of CDI in terms of CDI2, and also adopting CDI throughout the platform by making EJB services available outside of EJB as CDI, as plain CDI-based services, the pruning of the EJB platform itself, the pruning of JSF managed beans and the like. And also, of course, some staples in terms of incremental features for enterprises. So these are things like security, caching via the JCache mechanism, as well as some enhancements to the JMS platform. And finally, some alignment with Java SE. And we'll talk more about this, but basically, Java E as a platform always adopts ideas, core changes from Java SE. So obviously, similarly, Java SE 8 was very, very successful release of Java SE, and there were certainly things that Java E could adopt, namely in APIs like JSF and JPA and JAX-RS. So that is sort of the initial scope of Java 8. I'll briefly cover exactly all of those things. As it turns out, the scope did wind up changing, and not without a bit of drama, and we'll talk about those things as well, and how it pertains to where Java E is going in the future. So the biggest change easily in Java EE8 is support for HTTP 2.0. So for those of you who are not familiar with HTTP 2.0, it's definitely been well overdue. The last change in HTTP protocol happened just about a decade ago. And really, the world has changed since HTTP 1.1 and HTTP 2.0. And HTTP 2.0 really needed to reflect that changed world. So to briefly describe the problem, back in the world where HTTP 1.1 was invented, the web looked a lot like your typical Wikipedia page. So you would load up a page, it would basically be markup, and that would be the principal content of that page. Maybe there would be an image here and there, and mostly it would just be hyperlinks. So it would really be one HTTP request loading a single page and then you click on another hyperlink and it would load up another page. And it literally is mostly a one-to-one mapping between a request and a response. Now, if you look at the typical web page today, though, that's definitely really not the case. So if you look at a typical web page today, when you make the initial request for that page, you definitely will not be able to render that page right away. In fact, in average, there's some statistics out there that says you actually need to do 41 different requests, so 41 different resources on that page before you're able to render the page. So these are things like embedded JavaScript, embedded images, videos, multimedia, so on and so on and so on. So what that means is that HTTP 1.1 is a highly inefficient protocol. So in order to just make one page render, it literally is setting up and tearing down 40 different connections to render that single page. So HTTP 2.2 is a recognition of these problems and an optimization of the HTTP protocol to make essentially the web much faster, sometimes on average about as much as 5 times faster. So these are things like, first and foremost, reusing those connections. So instead of creating 40 different requests, it really is just creating one single request and multiplexing those 40 resources from the server through that one single request. There's many other optimizations to go along with that. So moving from an ASCII-based format to a binary-based format, which is much more efficient. Doing proactive server push. So the server will tell you these 40 that you need these 40 resources to render this page instead of you parsing the page to figure it out. Things like stream prioritization to more efficiently render a page, doing the much less repetitive header exchange and doing header compression and the like. So one of the very nice things about HTTP 2.2 is all of these changes are really at the protocol level. They're not at the API level. It's essentially preserving HTTP protocol semantics. What that means is that the Servlet 4 API, being an API that is relatively abstracted from the protocol, can absorb these changes without really making very many changes for the applications or on the API side. So literally, you should be able to adopt a Servlet 4 engine without necessarily needing to make many changes, and have your applications load up potentially 5 to 10 times faster. So that's really big news, and really, it's as I said, it's one of the most significant changes in Java EE8 very easily. It's not entirely without change. There is one change that did need to happen, and that is a server push API. But frankly, even that is not that important because you can opt into the server push. So you can adopt server push and make changes to your application when you need to, but otherwise be able to take advantage of HTTP 2.0 simply by upgrading your servlet engine. JSON binding is another key changes that I think is been relatively well received. So the goal here with JSON binding is really much like what happened way back in the day with JAXB. So it's essentially having a first-class support for JSON processing in the platform. So you don't have to integrate a third-party library, or you don't have to do anything really very special to just be able to parse JSON in a highly declarative fashion. It's sort of like you can think of it as yet another serialization format for Java, literally speaking, as long as you're on the Java E platform, of course. It is largely intended to work as is. There is a small number of customizations that are also available. So things like being able to rename property names or hide some property names and the like. But other than that, it's really just is a matter of taking a POJO and being able to parse it just like that to and from JSON, which is extremely powerful. Now, of course, one thing to note is that even if you're not using Java E8, even if you're using Java E7, Java E7 actually, as long as Java EE5, Java E platform generally have had support for JSON binding for a little while. All that this is really doing is that it's reducing the need for third-party APIs and enhancing the usability example quite a bit. For example, let's take a look at this code here. So what I'm trying to do here is I have a simple REST endpoint that produces a person. All I really need to do is treat the POJO though exactly as a POJO. I don't need to annotate anything at all, and I'm simply returning this POJO back from my REST endpoint. And lo and behold, everything will actually work in Java E8, simply because I have the produces annotation that says, hey, I'm producing an application JSON. Please parse this and create a sensible JSON rendering, and you can see the example of what kind of JSON would potentially be rendered. And all of this is really happening is because the Java 8 platform now has a default JSON binding provider that would just make all of this stuff happen without your needing to do anything at all. So in addition to the binding API that was introduced in Java E8, there was also a lower level JSON processing API added in Java E7. To some degree, you need to do that. And in fact, there are cases where you would want a lower level processing API. For example, when you have highly customized needs or your JSON processing needs are simply very, very simple. In fact, I wind up having used JSON-P more often than I would JSON-B for those reasons. So in Java E8, there were some minor changes made to the JSON-P API, principally to take advantage, again, of the changes that are happening in the web standards world, namely two different standards, JSON pointer and JSON patch, and also a little bit of Java AC8 alignment also happened here. I'll talk a bit more about that as I talk about more holistically all of the places where Java EE as a platform adopted to Java AC8. But here's an example of JSON pointer. So if you're familiar with XPath from the XML world, this will look very, very familiar indeed. So what JSON pointer in a nutshell is that it is something that looks like a URL, look like a URL, but it points to a specific location in your JSON document. So essentially, as you can see in this code example, as long as an API like JSON-P has support for JSON pointer, you don't necessarily have to write all of this procedural code or complex navigational code to get to a particular element in your JSON. You can simply construct a JSON pointer URL and have the runtime do that work for you, as you can see in the example here. Another very, very important change adopted by the JSON-P API, JSON-P 1.1 API, is something called JSON patch. And JSON patch is interesting for a number of reasons. It goes along sort of the HTTP patch API. It's a powerful paradigm for, especially for HOS, hypermedia as a mechanism for state management. What this does is basically allow you to make small changes to your application state by describing those changes in terms of JSON as well. So as you can see in the examples here, so I have two examples. I'm replacing an element and removing an element from a JSON body, and as you can see, JSON patch does use JSON pointer transitively as well. So there's a number of operations you can specify as JSON patch, as a standard JSON patch format. These are things like add, replace, remove, copy, test, and so on. Right? So very, very useful in terms of having a general purpose RESTful API for your application. So here's how the API looks like. Very, very straightforward. You create a JSON patch builder, and it basically, as the name implies, it follows the builder pattern. You construct whatever it is that you need in terms of a JSON patch object, and then when you're done constructing it, you simply do an apply, and the changes are applied for you. As you can see, I have a couple of examples from my prior slide, doing a replace operation and then a remove operation as well. So right now, the JSON patch is not integrated with things like JAX-RS, like JSON binding API is. So you definitely can receive just a JSON P 1.1 generic object as a input or output parameter to a RESTful endpoint. But one thing that would be very neat is to actually be able to receive input as JSON patch body, and instead of having to build the JSON patch body yourself, have a pre-processed JSON patch builder parsed for you by the runtime. But even then, I think this is a very, very useful change. You can obviously do your own parsing and construct JSON patches using this API right now. So one of the other very interesting changes and well-received changes in Java 8 was the capability of server-sent events. So in Java 7, what we did was we added another important protocol on top of HTTP, namely WebSockets. WebSockets allowed basically a fully bidirectional asynchronous communication over HTTP, over the HTTP protocol. Server-sent events was another variant that was added at the same time. But what we wanted to do is see, how well WebSocket was adopted before also introducing server-sent events. But surprisingly, when we put this survey out, Java 8 community survey out, SSC actually had very strong support. People wanted SSC support. So what is SSC for those of you who are not familiar with it? Simply speaking, SSC is a way of, instead of producing a single response to an HTTP request, producing a series of responses over a period of time. So if you will, a stream of responses over a period of time, or a stream of events over a period of time based on a single HTTP connection. So use cases for this is things like stock tickers or monitoring applications. So the idea here is that you would make a HTTP request to an endpoint that says, okay, I want to subscribe to stock ticker events. Anytime a stock value changes, send a notification to me via this HTTP connection that I'm making with you. And basically the server would send you bits and pieces of data over a period of time. The nice thing about this is it really is just vanilla HTTP. There's nothing too magical about it. The only thing that really is very special about it is the content type, which happens to be text/event stream. This is what differentiates it essentially from a normal HTTP request. For those of you who are aware, essentially the JAXA Jersey, which is the reference implementation of the JAXA standard, actually had support for SSC for quite some time. And in fact, what was standardized in Java EE8 and JAXA 2.0 is very much like exactly what had been there in Jersey. So here's a simple example of it. As you can see, I have a HTTP path called tickers. So this is a stock ticker example that I was talking about. You would make a simple GET request to subscribe to stock ticking events. And as you can see, the producer type here is text event stream, making this an SSC connection. And also, as you can see, the return type is void. So we're not really returning a single response. Instead, what we will do is open up what is called a SSC event sync, sort of a publisher, if you will, and produce events into that stream over a period of time. In this case, based on an asynchronous thread that I'm using through this injected managed executor service. And I'm essentially sending, whenever there is a new stock code, I'm sending that stock code over the wire through anybody that is subscribing to this particular stock ticker endpoint. Okay. Java security is a big one. In my mind, at least personally, this is a peer to Servlet 4 in terms of its importance and what it actually means for the average Java EE developer. This is literally a ground-up revamp of Java EE security. So Java EE security prior to Java EE 7 was relatively abstracted in the sense that there really wasn't very much of an API. A lot of the features were relatively dependent on implementers and runtimes. So all that the application really would do is you would say, this is a secure application. Please secure this application through this HTTP mechanism, let's say basic authentication or form-based authentication. and connect it up to this realm, so-called Java EE realm. And most of the mechanics would actually happen in the Java EE realm. So the Java EE realm would figure out, well, when I get username password, how do I validate those username passwords and the like. So those are things that were very highly application dependent. So that's a really good model for example, people that would not really touch security. They would just develop the application code, have some basic metadata in the application, and largely have an administrator take care of the details of connecting this application up to some database or LDAP security provider to be secured and the like. The problem with this approach, while that is a fundamental strength, the downside of this approach is that it does not lead to very portable code. So because you're so highly dependent on the container to provide all of these large-scale details, when you're porting from one application to the other, you have to redo that work. And it's not, if you will, very programmer accessible. You're not writing code to secure your application. You're really doing sort of WYSIWYG configuration, maybe through an admin UI to to secure your application. And it's a paradigm that's sort of alien to most other platforms. Most other platforms don't have dependencies on admin UIs and the like to secure their application. They're by and large embedding the security information within the application. So this is really what Java EE security is about. It's about addressing all of those problems by taking a ground-up look at Java EE security. And you'll see that by actually a simple example. So now, in order to secure an application, a Java EE application, all you really need to do is put together an annotation like this that says, hey, this is a secure application. Please secure it against this particular identity, what's called an identity store definition. So it could be, in my couple of examples, a database or an LDAP server. And this is it. This is really all you need to do in order to secure your application. So by these sorts of changes in Java EE security really does become one of the easiest things to do out there. So prior to this, by comparison, what you would do is you would do the same thing, but you would do that by pointing your application, creating a security realm in your application server, and maybe going through a few screens with wizards to define essentially this same information, but it would be outside of the application instead of being embedded within the application in this way. Okay. So there are a few of these built-in annotations. So these are database and LDAP. So let's assume for a second that your data store is something different from that. And you have some really custom thing that just built-in annotations in Java EE is not going to work for you. So what do you do there? So this is where custom identity stores come into play. And this is, again, a brand new capability, but it's super simple. So all you really need to do here is define a CDI managed bean. You can put it in application scoped annotation. That's the most sensible one for most identity stores. And then you can, lo and behold, do whatever it is that you need to do to secure your application. The key magic callback is a single method called validate. And what you do there is your pass unique credential, typically username, password, but it could be something like a security certificate as well. And then you do whatever it is that you need to do. In my case, I'm validating it against a custom coded service called user service, and you do the validation, and that's it. So instead of creating a built-in identity store through an annotation, you can simply create a custom identity store just like this, just by writing really not very much complex code. Another interesting thing that was done is a global security context for Java EE. So Java EE used to have many different security contexts, one for servlet, one for EJB, and so on and so forth. So instead of doing that, now you have a global security context. You can inject it anywhere you like. In my example here, I'm injecting it into an interceptor. I want to create a custom logger that logs out whenever there is an access. I'm injecting the security context and getting the currently logged in user and trying to see if the current user is an admin or not. So this is very, very powerful if you were to create your own declarative security-based model. Another key idea that was discussed but not implemented in this particular feature in this particular release was an idea of having EL-based authorization annotations. So you can see from the examples here. So in Java EE today, in terms of authorization, you really have two sort of extreme options. One is sort of a small set of built-in annotations that implements role-based security. So these are things like is in role. So is a particular individual, is a particular logged in user in a particular role, or run a particular role and switch the roles at runtime. Or you have the option of doing what I did before, which is basically write your custom interceptor, very low-level code, inject a security context, and do what it is that you need to do. This EL-based declarative idea is sort of a nice middle ground. It's a little bit of programming and a little bit of a declarative style. Okay, so CDI2 was another major change that happened in the Java 8 Java 8 timeframe. There's a number of important changes. The most important one is actually Java SE. This will actually become even more important as we go forward in the future of Java EE, because now CDI used to be just a technology limited to Java EE platforms. Now you can use CDI essentially anywhere, even in your own public static void main application. Another thing that was added was asynchronous events in CDI. I'll talk about that in just a second. One of the very nice things I really like about CDI is the portable extensions, SPI. You can do some very, very cool, almost unbelievable things using the portable extensions API. But principal focus of CDI today really is to enable the ecosystem and enable extensions to Java EE. So a lot of focus was actually put into making the portable extensions API even simpler and more powerful to use. And finally, there was also, again, a bunch of Java C8 alignment features that took place in CDI2, some adoption of completable features, adoption of repeatable annotations, and the like. So here's an example of asynchronous CDI events. For those of you who are not aware, CDI has a really nice polished event bus to it. You can essentially create very loosely coupled applications through type-safe events in CDI. The key artifacts here is the event object, and you can give it a payload. In my case, the payload is cargo, and then you can fire an event simply by saying, here's my event handle, and then fire this event with this particular payload. And then on the observer side, you simply need the @observes annotation, and then you can observe that the payload that was just triggered as an event. So this used to be all synchronous. So you would fire an event, and it would essentially trigger the observers in the same thread. Now you can do that asynchronously. So you can say fire async, and similarly on the observer side, you can say observes async, and the entire production and consumption of events will be completely asynchronous as opposed to synchronous, and that goes on. That is very useful in terms of more reactive asynchronous event-driven applications. JMS 2.1 is another personal favorite of mine. So what this is about is it goes along with the theme of CDI alignment and sort of making the features that were tied to EJB available outside of EJB. But frankly, it's a bit more than that. In the process of doing that, you can create a much better syntax for JMS listeners as opposed to an alternatives to an MDB. And you can also standardize things that were prior, that was not standardized prior to Java 8. So these are things like retrieval delays, retrieval limits, dead letter queues. These are implemented essentially by almost all JMS providers. They're just implemented in vendor-specific ways. So part of the idea in JMS 2.1 was to was to create a very high-level syntax like this as an alternative to MDBs. So this would be just a CDI managed bean, and lo and behold, you can just put in a JMS listener annotation and point it to whatever queue that it is that you're listening to, and you can do much more fancier things like automatic unwrapping of payloads. Like in this case, I'm not receiving a JMS message, but I'm wanting to receive the underlying payload, which is event handling registration attempt. You can apply selectors, you can do batches, and again, do things like retry delays, dead letter queues, ordering, and the like. MVC is a rather contentious but also very interesting idea that was proposed as initial scope of Java E8. And what this is basically it is a alternative to JSF. So JSF is the sole and actually continues to be the sole presentation layer technology for Java E. It's a very polished API. I'm a big fan of JSF. I would say it's the best way of developing UIs in a Java application if you don't want to depend on a whole bunch of JavaScript developers in-house, and you can still create a very polished API, and it's very, very compact and very, very powerful. The code winds up being very, very small. The problem with JSF, though, is in order to do those things, in order to make you productive, and in order to not have you muck around with a lot of JavaScript, and in order to keep the code as small as possible and as closely aligned as possible to true MVC, you have to create abstractions. And those abstractions are not very good if you want to do the opposite thing. Namely, you want to incorporate a whole bunch of JavaScript functionality into your front end. Something more primitive, if you will, that has a lower level of abstraction, like the traditional action-based web frameworks, those are more conducive to doing that sort of thing. So the idea here was to introduce just such an action-oriented framework as part of Java E. Most of the work actually is already done. The major pieces are already there. So the controller pieces can mostly just be JAX-RS, as you'll see in my example in a moment. The views are already there. So, in terms of view layer technologies, we have both facelets and JSP in Java E already, so you don't need to reinvent those. The model you are really mostly there as well. So you have CDI, bean validation, and JPA as a model. So really, it's about putting all of these existing pieces of Java EE together to create an action-based framework. And an example could be something as simple as this. So let's say you have a bookstore, and as you can see, this is mostly just reusing the JAX-RS annotations. So the path annotation is reused from JAX-RS, and the get annotation is reused from JAX-RS. In order to render an index page, you would simply inject a model object and then populate that model object and have that model object populated in the view layer, perhaps using JSP or facelets. So really the only two annotations you actually need is a controller annotations to differentiate this between from a regular JAX-RS bean and a view to say, okay, this is the view that you should attach this controller to. So really it can be a relatively usable API without adding too much complexity or needing to do too many things that are new. So as I mentioned before, one of the key characteristics of Java EE is that it always adopts the features that are introduced in Java SE. So a great example of this, again, I mentioned this towards the beginning of the talk, annotations are a great example, right? So where annotations are introduced in Java SE, but really brought into the enterprise through things like Java E5. So similarly, there's a lot of features in Java SE8. It's a good solid release, so things like lambdas, repeatable annotations, daytime API, completable features. Most of these features in Java SE8 actually are forward compatible. Namely, lambdas are a very good example. The daytime API is also a very good example. So what this means is that you can, by and large, use those Java SE8 features in existing Java EE 7 or Java EE 5 or Java EE 6 applications. But there are some cases where you need to make changes in the platform to make take better advantage of Java SE8 features, things like repeatable annotations, things like the completable feature. And these are the various APIs, as I have listed in this slide deck, that could use those features. So I'll show you a few examples of what was done here. So it used to be that you couldn't repeat annotations in Java SE. So now Java SE8 allows the repeating of annotations. So what this means is that in Java E7, if you needed to repeat annotations, the way you would really do that is you would create this sort of artificial wrapper annotation called named queries to group together a bunch of named queries for a given entity. Well, you don't need to do that in Java E8 anymore because now Java SE allows repeatable annotations. So you can just list out your named queries. And similarly, there's a number of places where there's similar changes in JPA. So, the datetime API is, again, another important change that was principally made in bean validation, JSF, and JPA. So prior to Java E8, you couldn't use the datetime API in an entity class and have it be automatically handled in terms of in terms of the ORM layer, translating it back and forth from the database. You could do that if you were using the old date classes, right? So the date classes are recognized, that translation would happen automatically, but not so for the new datetime APIs, because the underlying runtime simply wouldn't recognize what these objects are. But now they can. So now, as of Java 8, Java 8 natively supports these datetime APIs. So you could do something like my example here and have it just work automatically. You don't have to do anything to make it work. Same thing for JSF, and even same thing for bean validation. In fact, I have a bean validation example here. As you can see, the at post annotation from bean validation is actually recognizing the instant class from the datetime API. Completable features are, if you're not familiar with them, they're a little bit more involved. They're essentially promises for Java. They are a way of handling future events that are non-blocking and composable. Okay, so there's a number of places in Java EE where it makes sense to use completable features. In fact, wherever there is a usage of Java util feature, you can replace those APIs with completable features, which again, compared to Java util feature, is non-blocking and composable. And certainly that was done. So one big example of that is with JAX-RS, the JAX-RS client API. So in the JAX-RS client API, you used to be able to do asynchronous events through either util feature or callbacks. Now you can do that through completion stage and completable feature. So again, much more robust API for handling asynchronous events. So these are not the only set of changes that are there in Java 8. There's a number of other ones there as well. A few of them I have listed on here. For the interest of time, I won't cover them in great detail. You should have access to these slides later on, and certainly you can take a look at these. All of these are valuable things. And even this is not a comprehensive list. There's a lot more in Java 8 that has happened beyond this. So hopefully I've convinced you by now that Java EE8 is a worthwhile set of changes, even if you're not using only Java EE as your application stack. So these are all of those changes that we talked about. And so the big concern here, and why I have this slide, is that we did, despite the fact that Java EE8 was so important, we didn't arrive at Java EE8 without some struggles. So namely, what happened was after the Java 1 2005 timeframe, what we observed is that basically all work on the Java EE8 suddenly stopped from the Oracle spec leads. And for those of us that are involved in the Java EE specification development, we had never seen anything like this before. The only time we've seen anything similar is from during the transition from Sun to Oracle, but even then it wasn't such extreme durations. It was almost 6 months that we saw absolutely no work coming out of Oracle at all to move all of these important bits of work forward. So what we did in the folks in the community is we got together and we created this grassroots organization called Java EE Guardians for the principal purposes of evangelism and advocacy, kind of what I'm doing today, but also to address this problem of Oracle not investing in what they committed to in terms of Java EE 8. But after a few months of struggle, Oracle did come back and say, yes, they're recommitting to Java EE 8. They did that through creating yet another survey, similar to the initial survey that was created to determine the initial scope of Java EE 8. It seemed like the purpose of the survey was to figure out whether the scope has changed or what have you. In addition to Java EE 8 features, there was a lot of forward-looking features, stuff that I think now is implemented by the microprofile folks. But at the end of that survey, Oracle did commit to releasing Java EE 8, but with a slight alteration in scope. So these are the elements that you can see that has changed in scope. Largely, the initial scope of Java EE 8 has been intact. So the most important bits still are there. Thankfully, but what the things that Oracle wound up dropping is not doing things like the JMS work to maybe finally get rid of or create an alternative to EJB altogether. They didn't quite want to do the JCache work that they initially committed to, and they didn't want to do the action-oriented web framework work either. But thankfully, the MVC or action-oriented web framework work wasn't dropped altogether. Rather, it was given to the community. And in fact, the community is almost ready to make the final release of MVC very, very shortly. So that work, although it's not part of Java EE 8, in effect is available now for Java EE applications. So last Java 1, we really had some very good news coming out of Oracle, the stewards of Java EE. The first is actually the release, finally the release of Java EE 8 and Glassfish 5. That's been relatively well received by the community. Vendors are aggressively pursuing compatibility. So we've seen work towards adopting Java EE 8 from Red Hat. We've seen it from Payara. We've seen it from IBM in terms of their WebSphere Liberty profile product and Open Liberty products. So all of that is looking rather good. So you definitely have Java EE 8 in your hands already in terms of Glassfish 5. But beyond that, all of the vendors are doing a pretty good job of making it available to you right away, and so that you can use all of these features that I talked about as soon as possible. So the other really big announcement, and that we weren't quite expecting, but has been very, very well received by the community, is that in addition to delivering Java EE 8, Java EE is actually now moving to the Eclipse Foundation. So you really have to think for a moment and think about the significance of this change. So now you have this really important part of the Java platform, namely server-side Java, not being controlled by a single entity like commercial entity like Oracle, but instead moving into truly the open source domain, where it's not controlled by a single entity. It's controlled essentially by the community, and where a bunch of vendors can work together in completely neutral ground. So as a result of this move, though, the one unfortunate thing that happened, and that the Java EE Guardians actually objected to, was that now Java EE is no longer called Java EE. It's called Jakarta EE, which is not altogether a bad name, but it is now essentially finding a new life and a new beginning. Java EE, a new beginning under the Eclipse Foundation. Most of the Java EE Guardians are involved in the Jakarta EE work, and certainly we would encourage you, or encourage all Java developers to now get on board with this and to help out and make sure that the right things happen in terms of moving forward Java EE as a technology under the Eclipse Foundation, under the name of Jakarta EE. So definitely do stay tuned in that work. Hopefully I plan to come back and present sort of a Jakarta EE 1.0 talk and tell you about all of the things that are happening there. And one of the things that I would like to really talk about towards the end of this talk is what is next for Java EE. So obviously the things that are next is, could be next is the things that Oracle dropped, right? So things like the JMS work and the JCache work, that work could be taken up. And also all of the different things that are done in the microprofile community. So things like OAuth OpenIDJWT, dynamic configuration, fat jars modularity, health check metrics, circuit breakers, fault tolerance, distributed tracing, OpenAPI Swagger integration, dynamic discovery, client-side load balancing, NoSQL. These are all things that are possible candidates to be included in the Java EE platform. Now, when I talk about this, one of the reactions that I also get is that these are all relatively not that frequently used features, right? They're really features that you would use if you're going whole hog microservices solutions. So what that means is the Java EE as of Java E8 actually is a relatively very feature complete platform, except for the cases where you're doing serious microservices development. So definitely, I think a next division of Jakarta EE or Java EE Next could look to standardizing all of these features. The really good news is all of these features are already implemented by all the Java EE vendors through the microprofile initiative. So what that means is the next division of Java EE could be relatively very, very rapid and simply a matter of bringing in the work that was done in microprofile into Jakarta EE or Java EE Next. So in summary, Java EE, I think very obviously remains vitally important to all of us. Java E8 has a number of very mission critical features that I talked about in this talk. Obviously there has been concerns, but the really good news now is that Java EE truly is in a very, very open path, and it is in every single sense an open platform, more than it has ever been. And we should all get involved in it. We are from the Java EE Guardians community. You should as well, and perhaps you could do that through the Java EE Guardians community if you so wish. And certainly, one other really good thing is the microprofile initiative that hopefully a lot of the work that's already done and released through microprofile can help accelerate the next release of Java EE very, very quickly. So that is all I have for you today. I have just a few minutes for Q&A. I will now take a look at, I'll stop a moment, and I will, hopefully you can see me. Excellent. And I'm reading, looking through the questions right now that you guys have sent in the chat. Feel free to post more of them. And then I will just read off the questions here and answer them for you. So let me take a look. Okay, I think we're all good for now. There's one more minute. Thank you all for attending, and see you soon. And remember to, the slides are already out there. If you want to take a look at them, they're already in speaker deck. They're just updated them right before this talk. And if you have any other questions, my time is up for today. You can certainly email me, and I'll be happy to answer them for you. So thank you very much for attending, and I hope you enjoyed the rest of the conference.